So what I'll try to cover is basically give you an overview of the kind of work that I've been involved with over the years. And I sometimes now feel like a bit of a dinosaur when I'm describing these kinds of things, but that's just how it works, I guess, when you get older. So as Henrik said, I'm a psychiatrist by training, and I always emphasize this because I'm not a trained scientist. Yeah, so I sort of started to venture out into this field of social neuroscience, always coming from the clinic, from seeing patients and thinking about what could be helpful for them and how to understand problems in social interactions. So in my talk, I'll try to see if we can bridge and meet social neuroscience and clinical psychiatry. So to give you a bit of an overview, those are the kinds of topics that I would like to cover. So give you a bit of an introduction, why I think we really need to study social interaction to understand the social brain, how we have been able to do this or how we've tried to do this over the years, and what this may mean for psychiatry and for what I call disorders of social interaction. So translating this kind of second person approach to psychiatry. So to begin with the introduction, I'm a big fan of Calvin and Hobbes, and this still today ranks very highly, in my opinion, as a really nice description of what social neuroscience is all about. Yeah, so it's about the study of knowing other minds, and of course thinking about how this may be related to brain processes. And of course, there can also be situations like the one depicted here, where you may think that something could have gone wrong in another person's brain in order to explain his or her social behavior or erratic behavior. And this is where the second person notion comes from. So this is a very old slide that I put together with Bert Timmermans and Tobias Schlicht, probably something like 12 or 13 years ago, when we were preparing for a grant proposal for a talk that we were giving, and we tried to describe these different ways in which people can think of other minds and of knowing other minds. So on the one hand side, this idea that this might be sort of more of an abstract theoretical enterprise, so you posit mental states and attribute them to another person, so using this sort of third person approach, as compared to this idea that you may actually use your own mental states in order to simulate what may go on in another person's mind that has sometimes been described as a first-person account of social cognition. And so almost by logical necessity, we thought that there should be something in the middle between first and third person. And that, of course, is the second-person approach to other minds. So this idea that social cognition and the relevant brain processes could actually be fundamentally different when we are in an interaction with another person as compared to when we observe them. And this is something that at the time when we developed this was also sort of noted in neuroscience. Of course, we've traveled a long way, but this is sort of an old quote by Thomas Insel, as someone who was an important person back in the day. So saying that neuromechanisms that facilitate social interaction may have actually been more difficult to assess. And some people thought that this could actually constitute what you might describe as the dark matter of social neuroscience. So this is sort of from this old paper from 10 or so years ago. And in the meantime, what of course we've seen is that many people have picked up on this idea and have really presented beautiful work, I think, which has helped us, to learn much more about the neural mechanisms of social interaction in individual brains, but also across brains. So I think this is really sort of a very exciting development that many people are contributing to. How is that related to psychiatry? So psychiatric disorders today are highly relevant. This is because, for instance, as you can read here in the Lancet Commission report, many countries are failing to tackle mental health crisis. And this was already true before the corona pandemic, and it's a huge problem in terms of a loss of human capabilities and suffering. And the question, of course, is why? Are we not in a good position to tackle these mental health issues? And of course, those are more difficult conditions, presumably, than some other medical conditions. People have argued. So the question is, what can we do and how do we approach sort of psychiatric disorders today? An important research strategy in the past, which was also promoted by the NIMH, was to say that we should focus on mental illnesses as real, diagnosable, and treatable brain disorders. Yeah, so this is Stephen Hyman, so the director of the NIMH for some time, who sort of coined this phrase. And the idea, of course, in terms of research, means that we should be interested in this sort of mapping between psychiatric disorders, you know, that you can diagnose by clustering certain symptoms and then think about how this may be related to the brain. Yeah, if you follow this kind of rationale and logic. This is the successor of Hyman. This is Thomas Insel, and when he was sort of at the head of the NIMH, suggested that he wanted to move away from diagnostic categories because he realized that this might not be the most sort of effective way to actually investigate this relationship between mental health and the brain. And his suggestion was that we would have to actually resort to psychological constructs. So it's not a direct one-to-one mapping, but we should actually understand psychiatric disorders in terms of the underlying psychological constructs. And he coined this sort of RDoC framework that also sort of uses insights from cognitive science and psychology to augment the assessment of symptoms. And after doing this, Thomas Insel did something interesting, namely he left the NIMH and said this, namely that he got a lot of cool papers published, which of course is always exciting and interesting. It's also quite expensive, $20 billion. But he also realized that this approach had not helped to move the needle in reducing suicide and reducing hospitalizations, which I think is quite a sort of candid statement, quite an candid statement to make for someone in that position. And this brings me to my own ideas about psychopathology and the question: how do we actually describe and characterize psychiatric disorders? An important point to note is, and this is sort of from old German psychiatry textbooks, is to note that behavior per se is never abnormal. This, of course, is sort of an old-fashioned term that we may not use today when describing psychiatric disorders, but the idea is basically that you need to also consider context. So behavior becomes abnormal due to a lack of signals which indicate that an individual intends not to adhere to the conventional agreement of respecting the rules of the game. So this sort of refers to the kind of social conventions which govern and make understandable whether or not a person behaves normally, respects conventions, or doesn't. Yeah, and this may be an important indicator for when we may have to think about whether this is an abnormal behavior that could be indicative of a psychiatric disorder, for instance. So knowing the social rules seems very important. And this is also something that you can find in different sort of descriptions of psychiatric disorders, for instance, autism. So this is a description from Asperger, where he describes how a boy with autism, spectrum disorder, as we would say today, shows abnormalities in nonverbal behavior, which impact how in a social interaction this person will be perceived. Yeah, so Asperger writes, and this is my own translation: human beings and things he only seems to glance at with short peripheral views. It is as if he was not there. And of course, Asperger doesn't mean that the boy wasn't physically there, but psychologically wasn't connected to him, wasn't engaged in an ongoing social interaction. Yeah, was not building rapport, and the reciprocity of the social interaction was diminished, which sort of affects him as a psychiatrist or as a pediatrician back in the day. Yeah, so also here, sort of the way we establish social relations with other people is described as being sort of characteristic, of course, of something that we call autism spectrum disorder today, but we can also find this in other sort of psychiatric conditions. Another point to make is this idea of a bi-directional relationship between mental health and social functioning. So we know that if your mental health goes down, let's say you develop a form of depression, this will affect your level of psychosocial functioning. It will go down, you will maybe show signs of social withdrawal. But of course, the arrow goes in the opposite direction as well. So whether or not you experience social support or social stress also has an effect on your mental health. And another point, which I think is also important and also relates to what has been described as, for instance, the double empathy problem in autism, is this idea that when you take the social interaction and both participants of a social interaction into account, you will also have to think about the kind of matching between persons that may be relevant for communication success. Yeah, so this idea that in biological psychiatry, we often focus on this sort of case here in the middle, where we think about how a psychiatric disorder may affect one person and how this may lead, let's say, to a breakdown of social interaction. But of course, it's also interesting to observe what happens when, for instance, two persons with autism are in an interaction. And I come back to that point later on. So our idea, of course, over the years has been to say, we should really focus on the characteristics, the dynamics of social interaction as this sort of intermediary, linking the diagnostic classification of a psychiatric disorder to the kinds of neurobiology, the behavioral mechanisms that we may observe when two people are interacting. So trying to find ways to do what you could call interaction-based phenotyping, so providing quantitative measures of social interaction, and then using these measures to sort of guide the investigation of the underlying neurobiology, for instance, and see whether that's useful in terms of predictors of diagnosis, but also in other areas of clinical psychiatry. And this is sort of from a more recent paper where we try to describe that you can use these different methods of deep phenotyping in different contexts, things like smartphone-based assessments, but of course also tracking of dyadic social interactions, and then combining this with other sort of, let's say, more established and conventional ways in which you can look at psychophysiology and neurobiology. And down at the bottom, you see this sort of gradient where we try to indicate that maybe the manifestation of social symptoms that you may find ubiquitously across psychiatric disorders may actually be differentially different depending on the kind of context in which you investigate them. So ranging from more, let's say, controlled lab-based experiments all the way to more naturalistic situations. And that this may actually be quite important if you wanted to look at social impairments that are related potentially to psychiatric disorders. So that much in terms of an introduction, and then moving into some of the research that we've done. So starting first off with this idea of interaction-based phenotyping. So during my time in Munich, one of the things that we worked on a lot was to try and establish an infrared-based motion tracking system that we could use to track dyadic social interactions between two persons. And the rationale or the motivation was to find a solution that could also be used in the hospital, in the clinic. So in contrast to, let's say, more established ways where you use sensors, as you can see here, that you put on people's heads or on their hands to measure their movements, etc. And in a validation study, we compared our new system to these kinds of inertial measurement units, that you actually have to stick to people's bodies, which is a problem because putting a sensor to a person immediately, of course, changes a lot of things for the person. And of course, also their awareness of being measured will very likely affect how they're going to move, etc. So we wanted to have these sort of infrared-based sensors where it says Connect sensors here. So these are taken from this sort of Microsoft Kinect system that some of you may know from a video game console. So this is a commercially available system that you can also use to play video games. So you can sort of stand in your living room and move, and the sensor will recognize that there's a body and will translate your behavior into the kind of input information that, let's say, a video game needs, so that you can play tennis or something like that. And our question was, can we tap into the system and use it for scientific purposes? And our idea was that we wanted to establish quantitative measures of interpersonal coordination. Yeah, so for instance, being able to measure the distance between two persons, but also measure, the head direction where people are looking, to see whether they're establishing neutral gaze or whether they're looking away from each other, and then also try to establish ways of using this information to characterize the dyad in terms of relational information. Yeah, so how behavior of person A and B are actually linked to one another. So in analyzing, for instance, the gaze direction of person A and B, simultaneously to evaluate whether these two persons are spending time, for instance, in different gaze states, that you can see here. So depending on the kind of gaze angle deviation, from looking at one another, so 0 degrees being they both look dead center at the other person, to 90 degrees, so looking away from the other person. And you can define these different gaze sort of states, where both people have a low gaze angle deviation, which may indicate that they are engaged in eye contact. And this is something that we've used raters to verify at the beginning before we made this a more automatic tracking system. And then you can also track states like shared or joint attention. So when the two persons are looking at a game that they play. So we had this little game, which in German is called Zitternix or Mikado. So you have these wooden sticks, a bundle of wooden sticks that's placed on the table. So when both people are looking there, we can measure the amount of time or the percentage of time spent during the entire interaction in this particular gaze state, for instance. So just to give you an example of what this looks like, you will see in the short video, you have these sort of skeleton model, that the tracker integrates when it picks up that there's a sort of a human body moving around, and you can see how basically the tracking works when two people are playing these games. So they're taking turns, taking these wooden sticks, and you can see how these kinds of plots that are related to interpersonal distance on the top in the center, or these sort of gaze state measurements, so how much time is spent in eye contact or in joint attention, you can see how they're building up. On the top left, you also see a measure of interpersonal synchrony, so how behavior of person A is related to one another, for instance. And of course, we were interested whether those kinds of measures are actually related to subjective experience. So after these games, we asked people how much they enjoyed playing with the other person, how much effort they spent, how engaged they were, and those kinds of things, to then investigate correlations with our measurements obtained from the sort of motion tracking system. And one thing that we found, for instance, is that dyads that indicated that they really enjoyed playing with one another are actually the ones that were sitting closest together, so whose interpersonal distance was the lowest. We were also interested to explore autistic traits in this sort of healthy control cohort, and we didn't find very much for the different parts of this sort of experiment. So when people were having a conversation, or when they were playing a practice or cooperative or competitive round of this game that I told you about. But interestingly, between trials, so when they were asked to wait for the next round of the game, we see that there's this link and this positive correlation with autistic traits. Such that people high in autistic traits are actually the ones that have the highest interpersonal distance selectively in these situations when they don't know exactly what to do and when they're waiting for the next part of the game, which I think is quite interesting and bears some resemblance to what we also see in persons with a formal diagnosis of autism. We also looked at these sort of gaze state measures where we see, for instance, that dyads that indicated that they put a lot of effort into being good at the game, actually the ones that spend more time, significantly more time, also in eye contact situations, which is interesting because, of course, this is also a strong, let's say, communicative cue when you engage in eye contact with another person. So this is one way in which we try to measure sort of behavior in social interactions. Here's another one. This is a setup that Dimitris Bolis, who's now working at the IIT in Italy, came up with. So he wanted to also study two persons and do so while providing also a highly controlled task. So he placed two persons in front of two computer screens, which he could use to present stimuli. And the interesting sort of part of this setup is that Dimitris, who has an engineering background, which you may guess by looking at this sort of more technical setup, he used micro cameras that he attached to the center of the screen in such a way that people could actually have eye contact through this sort of live video broadcast. Yeah, so this person that you see in the front here sees the other person's face as it is currently filmed by this camera, and vice versa, right? So you can basically engage in eye contact while you still have the possibility to look at these sort of this wide section of the screen where we would be able to present stimuli, for instance, as part of a perceptual decision-making task. You can also use eye trackers to precisely measure where people are looking. Dimitris has also used EEG in a subset of these studies. So you have a sort of fairly comprehensive two-person psychophysiology setup that you can use. And one of the first studies that Dimitris did was to investigate whether social interaction, so gaze-based social interaction in this case, matters even when it's not required. So he asked people to perform a perceptual decision-making task where they were asked to find the odd one out. So detect one set of GABA patches, there were 4 on the screen, that would be different from the other ones. And they would have some time to explore this and then would have to make a decision and also indicate their confidence. And what's interesting about this task is that both people have to do it, but they're told that this is an individual task, and they see the other person, and the other person's screen is actually mirrored such that what's on your left-hand side of the screen is on the right-hand side for the other person, in order to indicate that you can actually look at the stimuli together. Yeah, so when I'm looking left and the other person is looking right, we're actually looking at the same stimulus. But it's really your own task, and you gain your own points, etc., when you sort of correctly identify the odd stimulus. While in fact, there in this task, there was no target, there was no odd one out, right? So this task was actually physically impossible to solve. And the only information that was there was the gaze behavior of the other person, who of course, at the same time was also solving an impossible task. And the reason that we set this up was to investigate whether any kind of dynamic in the gaze behavior of the two persons would have an effect on decision-making, yeah? Whether this would help people to deviate from sort of chance level detection rates. And importantly, what we did in the task was to contrast two conditions. One, a live video condition where what I just told you was actually true. So I see the other person as he or she sees me in a live video broadcast, but we also used a delay system so that we would be able to generate a video replay so that you would not see the other person live, but would see a video image of the other person from 20 seconds ago, which for the participants is undetectable. So no one was able to actually notice this difference. But what it does is it breaks down the reciprocity of the social interaction and allows us to contrast how this affects people's decision-making behavior. And what you actually see is that in this task, even though people, would not have to pay attention to the other person or be influenced by their gaze behavior, this is actually what happens. Yeah, so you see that being engaged in this two-way interaction leads to gaze coordination. Yeah, so people automatically, spontaneously coordinate their gaze with one another because they see the other person looking around. And interestingly, this also influences what we call shared decision-making percentages, right? Which do not go up incredibly high, but they differ significantly from this sort of 25% chance level detection that you would have for selecting 1 out of 4 different stimuli. So this is interesting because it sort of indicates that people are really spontaneously coordinating their behavior, and that this is also affecting cognition, yeah, and shared decision making, even though it's not strictly required or introduced as necessary. So so much to the kinds of behavioral studies and that we've done, and then a bit more on the social brain. And here also comes some of the dinosaur bits that I mentioned at the beginning. So I'm still, even today, a big fan of fMRI. And this sort of, when I started moving into this direction, was a big problem. Because when thinking about social interaction and fMRI, you face this issue, yeah, namely that it's really very hard to put two persons into the scanner at the same time. So brave people have done this. I was never brave enough or clever enough technically, I should say. So I've stayed away from these kinds of solutions. And of course, today or over the years, we now see many other possibilities. Yeah, thankfully and intelligently, people have also moved away from MRI to some extent. So here you see a scenario from a recent paper by Atesh Kul, for instance, where you see these are more sort of naturalistic, ecologically valid situations, and people use different sort of camera systems and other tracking devices, and also neuroimaging markers such as EEG, which may be more easily used than, let's say, using a scanner, an MRI machine. We've been happy using what we call interactive eye tracking in the scanner. So this is a technique that we developed by using eye tracking data, gaze data from the subject that's placed inside the MRI machine. And we developed, and still until today, use algorithms that allow us to basically check where people are looking on the screen that they are shown inside the MRI. And we can use this information to change what people see on the screen. And for instance, we can use this to generate paradigms like this one. So here you see the blue asterisk, which indicates the gaze position of the participant. And we can use this position data to change the gaze behavior of the face that you see on the screen. So this is actually Marie-Louise Brandi, a former postdoc of mine. And we have these sort of video snippets of her. And we can make people believe by meeting Marie-Louise Brandi or another person whose face we've videoed, that they're actually interacting with her while they're lying inside the scanner and are looking at different objects. Yeah, in this way we can sort of look at the neurocorrelates of gaze-based interaction and have a nice way of systematically manipulating the kind of gaze behavior that people show. We can of course also show the face with its eyes closed as a kind of control condition for fMRI purposes. And in a sort of series of studies that we've done over the last 10 years or so, we've been able to demonstrate, for instance, that these kinds of very small interactions, gaze-based social interaction, are actually quite powerful and, for instance, differentially recruit reward-related neurocircuitry, yeah, which is quite interesting. These are sort of very fast, quick responses that you see, for instance, in the ventral striatum. We're also able to demonstrate that in other sort of contexts during the social interaction, the ventral striatum also seems to have a different role, sort of accumulating evidence over time, for instance, which may speak to these differences between the liking and the wanting function of these kinds of circuits, if you like that kind of terminology. Another thing that we've been able to show is that you can also make your brain less responsive to these kinds of gaze-based social interaction. And one way to do this is to use cocaine. Yeah, so this is a study that we did in Zurich together with colleagues Katrin Preller and Boris Kuetno, who recruited cocaine users that were far away from having any kind of psychiatric disorder or abuse disorder, but those were recreational cocaine users. And interestingly, we were able to demonstrate that there's a sort of hypoactivity in orbitofrontal cortex when they are engaged in this gaze-based interaction as compared to controls that have no history of cocaine use. Interestingly, the activity level in this region is also related to the social network size, so how many people actually and really meet in their everyday life, yeah? Which is interesting because it sort of begs the question whether this kind of underactivity in orbitofrontal cortex is the reason why people start using cocaine, or whether this could be a consequence of them having used it, which of course we can't answer in this cross-sectional study, but would be interesting to sort of follow up. Another way in which you can affect the neural correlates of gaze-based social interaction is to stress people, which is a study that Marie-Louise Brandi did in Munich. And we used an interviewing technique where people tell us about stressful events in their lives. And then you can sort of generate small audio vignettes and play them to the people inside the scanner. And this is sort of very effective in stressing people. Yeah, so they will report that arousal goes up, tension, that they feel sad because they remember these sort of socially stressful events, let's say breaking up with your partner or something else. And this sort of, even in the scanner, brings back these sort of memories and feelings of sadness, etc. Interestingly, it also has an effect on the neural networks. So here you see again a replication of results that we've seen in the past. So being engaged in social interaction in the scanner actually recruits the mentalizing network, or regions that have been associated with this, so medial prefrontal cortex, precuneus, but also temporoparietal junction on both sides bilaterally, which is interesting because, of course, we're not asking people to mentalize or to think about other people's minds, but this network still is very robustly activated. And if we look at what happens after being stressed, so the statistical interaction effect, we see that there is actually a set of other areas, that's differentially engaged, so including anterior cingulate cortex as a region that's been associated with sort of, conflict monitoring and those kinds of things, but also insular cortex, etc. So here again, we also see sort of strong effects on the kinds of neural correlates that you would see during social interaction, depending on stress. And sort of conversely, we actually see a different development in individuals that may have been chronically stressed, namely patients with depression that come into a psychiatric hospital and are being treated for depression. And here we see that these individuals show sort of a recovery of activity in these kinds of areas. TPJ, for instance, where they show low levels of activity that sort of recover and go back to a more normal level as compared to our control cohort that I've just showed you after 6 to 8 weeks of treatment. So which is also interesting because, as I've said in the beginning, the idea of psychiatric disorders being disorders of social interaction, we can also find some evidence here that this might also be relevant for depression. And of course, we also know that individuals with chronic depression, for instance, have problems in social interactions such that they will be biased in their ways of mentalizing, or may have also empathic difficulties, for instance, just as another example. And then sort of more recent work, which is not sort of from our lab, but from other people's labs, which I find really exciting, is this idea that we should also look at synchrony across brains, for instance. And this may mean, on the one hand side, looking at neural similarities, so comparing how similar brain responses are across different individuals in terms of inter-subject correlations, for instance, but also, of course, this idea whether there might be neurosynchrony when people are actually engaged in social interactions. This is sort of from a review article that has just been accepted for publication at the beginning of next year, together with Elizabeth Redkay, where we've tried to sort of review some of the developments in the past years. And I'll just give you 1 or 2 examples. So here, very exciting set of studies by Carolyn Parkinson, where she investigated social network and social distances between people in a social network, and was able to demonstrate that the social distance between people is actually linked to similarities in terms of neural responses. When she asked people to watch videos in the scanner, and was able to demonstrate that you see these links between intersubject time series similarities in terms of the fMRI data and the social distance that was measured before, by looking at how closely related 2 persons actually are. So sort of evidence for what you could call neural homophily, if you like. And here from, again, Atesh Kul's brilliant work, so this idea that interbrain neurosynchrony would be a very important sort of parameter. Also, of course, going back to Guillaume Dumas' seminal work in this area, and in Atesh's work, it was found that actually the interbrain effects are sort of linked and rooted in the reciprocity of the social behavior. So demonstrating that there's sort of a complex bidirectional relationship, of course, between behavior and the brain, but that when we observe these kinds of similarities and synchrony across brains, that this may often be preceded and causally linked to actually the reciprocity of social behavior, which I should find quite exciting and potentially also interesting for psychiatry, because there's also emerging work, for instance, by Eda Bilek, that some of you may already be familiar with, who investigated persons with a borderline diagnosis in interaction with a person without borderline by using, again, a very sophisticated two MRI machine setup. So people were actually in two different MRI machines interacting via a video link. And Eda then looked at measures of neural coupling across brains and was able to demonstrate that, again, TPJ is a region that shows neural coupling only when people actually interact. And she was able to demonstrate that these kind of coupling effects are not found in a diet that consists of a person with BPD and a healthy control, but that interestingly, when patients as a function of treatment get better and do no longer meet the diagnostic criteria of borderline personality disorder, you can actually then again find these kind of coupling effects, which is very interesting because this could be taken to suggest that those kinds of measures might actually be an interesting sort of marker, that could be used across a different time scale and in order to look for interaction effects. I'm not doing so great on time, if I'm not mistaken. So I'll very briefly go into the final part of the talk. So this is the outpatient clinic for disorders of social interaction here in Düsseldorf. Since we find this very important, namely to look at social interaction difficulties as a potentially unmet medical need, because it's often related to the occurrence of psychiatric disorders, we have a specialized clinic where people can get in touch with us and where we provide comprehensive psychiatric assessments, a full diagnostic workout, where we also treat individuals and help them to receive the kind of support that would be important for them. And of course, in such a clinic, but also in the past, for instance, in Munich, we've used, for instance, this motion tracking setup during so-called ADOS interviews, which is a typical instrument that is used for the description of autistic behavior when you do an autism workup. And you can see, for instance, here, if the video starts running, which it doesn't seem to do, but I will just show you the group effects that you can, for instance, use these motion tracking measures to detect group specific differences, for instance, in the time spent in eye contact states, which you can see here, that there's this difference between a group of persons that did not receive an autism diagnosis at the end of the workup as compared to an autism group. You also see that the interpersonal distance measures are actually more variable and negatively correlated with ADOS, and there's also some indication that there are differences in the cross correlations of behavior across the two persons during the ADOS interview. I'll maybe skip this part. So this is more about real-world tracking, where we use smartphone-based data collection and look at different, let's say, communication preferences, so verbal as compared to written communication. We find interesting differences there, such that autistic individuals seem to be more interested in using written communication on their phones as compared to actually talking to another person. We also provide sort of psychotherapy in our outpatient clinic and have developed this sort of manual with which we try to help individuals, first of all, find out about their social difficulties. So where in perceptual but also behavioral abilities they may have difficulties, and then, of course, help them during psychotherapy to improve on their social abilities, which is something where preliminary work shows that this is actually useful, and where we might also start using these sort of smartphone-based measures in order to see whether these kinds of improvements that we see in psychotherapy actually also translate into everyday life. I'll skip over the TMS stuff, if that's okay with you guys. We've just finished doing a TMS study where we use an excitatory protocol on TPJ in individuals with autism, which surprisingly worked quite well and helped us to improve social information processing in persons with autism, as measured by this sort of probabilistic social learning task that you can see here. So people have to learn which of two cards, a blue and a green card, will win them points. And they also see a face on the screen that looks at them and provides a cue. So the face looks at one of these cards before people are allowed to make a choice. And the probability of the card, of the gaze, being helpful or misleading is actually varied independently of the winning probability of the cards. We can assess using this task how much attention people pay to the face and how much they use this additional information to improve on their performance. And it's interesting to see that individuals with autism actually are not very good at using this helpful cue, which you can see here. For our sham group, so where we used a sham or placebo TMS, you can see the pre-post calculations here. So not much happens in terms of this gaze following behavior, but interestingly, in our Verum group, actually it goes up for the helpful condition, such that TPJ, neuronavigated TPJ-oriented TMS in autistic individuals seems to improve their ability to use this helpful cue. And with that, I'll end with my summary slide. And hopefully I've been able to give you some indications for this notion that psychiatric disorders are highly prevalent, severe disorders. We can think of them in different ways. So of course, disorders of brain circuits, but of course, we could also think of them as disorders of social interaction. And hopefully I've been able to convince you that this might be an interesting approach, and combining this with these kinds of novel methods, so interaction-based phenotyping, neuroimaging, etc., might actually help us to turn towards the quantitative assessment of social behavior, its change over time, and also its change as a consequence of interventions. And hopefully this approach will continue to provide new avenues for both fundamental but also translational research, and may help to focus on those processes that facilitate social information processing, social interaction and communication across individuals, but also across different groups of individuals. And with that, I'll thank you for your attention and would be happy to take questions if you had some.